Hello, my name is Shelly and I'm an undergraduate student researching for Dr. Yin at the University of California, Riverside. Today I'll be performing the synthesis of monodispersed nanoparticles of iron oxide in water phase. Prior to this video, the iron oxide nanoparticles have been transferred from oil phase to water phase through surface ligands. The water phase allows the nanoparticles to be soluble in polar solvents such as cadmium. We are interested in the synthesis of iron oxide nanoparticles because of its role in biological, therapy, and technological application. It is important to control the particle size as the magnetic, electrical, and optical properties depend on their size. In this particular experiment, we will be focusing on the fluorescence characteristics, as both fluorescence and magnetic properties would be useful and cost-efficient for the biological and biomedical application, such as biolabeling and magnetic resonance imaging. With that being said, let's get started on the experiment. The anion exchange reaction is iron oxide reacting with sodium hydrosulfide hydride to form sodium hydroxide and iron sulfide. For anion exchange, the materials needed are PVP, sodium hydrosulfide hydride, and iron oxide in water phase. This experiment is run in a vial equipped with a stir bar. First, we will add 500 microliters of iron oxide and then begin stirring. Next, we will add 3 milliliters of 5% PVP, followed by 1 milliliter of 1% sodium hydrosulfide. This reaction will stir for 20 minutes. Next, we transfer the sample to a centrifuge tube and add 10 milliliters of acetone to wash. After centrifuging, we remove the supernatant and add 2 milliliters of water. Then we sonicate it. The cation exchange reaction is iron sulfide reacting with cadmium nitrate to form iron nitrate and cadmium sulfide. In the cation exchange, we will be using iron oxide sample, 1% cadmium nitrite in water, and 5% PVP in water. In this experiment, we will add 2 milliliter of iron oxide sample, then add 3 milliliter of 5% PVP, followed by 1 milliliter of 1% cadmium nitrate. This reaction will take an hour to stir. After stirring for an hour, we transfer the iron oxide sample to a centrifuge tube, and then add 10 milliliter of acetone to wash. We centrifuge it at 11,000 rotations per minute for 4 minutes. Then we remove the supernatant and add 2 milliliter of water and sonicate. Finally, we transfer 2 milliliters of the iron oxide sample to the vial to be observed under the UV lamp. For this portion of the experiment, extra eye protection is necessary. When placed under the UV lamp, the iron oxide sample goes from dark brown to bright green. To analyze the particle structure, we first must look at the TEM image. The particle consists of a spherical shape. The diameter of one particle is approximately 20 nanometers. That was a synthesis of monodispersed nanoparticles of iron oxide in water phase experiment. In this experiment, we did an anion exchange before the cation exchange because if we had attempted the experiment vice versa, it would not have been successful, as anion consists of a larger size relative to cation, thus making the diffusion more difficult. This procedure can be improved and alternated as the fluorescence was not as bright as we would hope it to be. Thank you for watching, and I hope you enjoyed this experiment.